mail, if Cliff Clayton you're going to deliver a mail and send a mail, let's say we're going to send it to Europe, all right? You're going to write, and what are you going to put on the envelope? Audience participation only. What are you going to put on the envelope? You're going to send a mail to someone in Europe. An address! Woo! All right. I wish I had more Founding Farmers gift cards, but you get a thumbs up. Okay, so you put the address on this envelope, right? And then when you put this address on the envelope, you put it in what's called a mailbox. Oh, right. We're going along over here. Okay, so then Cliff Clayton, who's the mailman from Cheers, great, one of the best series of all time, picks up this envelope, and where does he take it? Takes it to the post office. Can he take it anywhere else? No. His job is to take it from the post office, from your house or from your office, and goes to the post office. Now, even if he was mailing it to let's say I was mailing in here and I was mailing something to Founding Farmers, he can't actually deliver it to Founding Farmers. He's got to go to the post office, and then Cliff Clayton the next day, then take it to Founding Farmers, right? I just want to make sure we all understand how the postman works. I used to work in the Postal Service. I didn't. I'm just joking. I just want to see if anyone's paying attention. All right, so after he goes to the post office, the mail goes to the post office, and what do you think happens? I even included it here, so you guys can just read along with me. It's sorted, right? And then it's determined, does it stay in Reston, or does it go somewhere else, right? All right, so are you all following along? Yeah. I want to see nodding. I want to see nodding. I want to see participation. All right, so then it goes from our Reston post office, and where do you think it goes? Springfield. Merrifield, exactly. It goes to Merrifield, right? Merrifield is our regional post office for the USPS, right? All the mail, Cliff Clayton picks it up, he gives it to Betsy, Betsy gives it in, it goes, and actually it's a machine that does it, I don't know the name of the machine, it goes back and forth, and then it goes to Merrifield, and then Merrifield then has to make a decision, are they gonna send it to Centerville, are they gonna send it to Oakton, are they gonna send it somewhere else regionally, or are they gonna send it to Europe, right? So it goes through this process over and over again, until it gets to the next regional location. Finally, it goes to the Cliff Clayton in Europe, who's going to deliver this message to the person that received it. Does that make sense to everybody? Okay, internet works the exact same way. Now this is the best. I came up with this analogy in the shower and I drew up this presentation in about 5 minutes today. So if you don't get it, we'll work on something else. But I think this was you're gonna see how we're gonna go over here. So finally the mail is delivered to the final address. All right, let's follow through our example here. And I'm drawing us, we're living in Seattle right now. Close your eyes, we live in Seattle. And we have our mail goes to the post office, it goes to the next regional one, it makes it across the makes it across the Atlantic Ocean. Michael Phelps swam that, we don't, okay? It then goes to the next regional, and then it gets delivered, okay? So that is the same thing, think of that mail making it from person to person. Every time it goes to a regional hub, there's a decision made. Do I send it regionally? Do I send it here? Do I keep it regionally? Do I keep it here? Think about that. That is how the internet works. That is how routing works. Now, what I want to talk to you about is what is a router. So a router, everyone has one if you're at home, right? You got a Verizon router, a Comcast router, whatever it is. And it basically routes connections. But if we think of it on the internet side, we have multiple tier ones, right? So I don't know, guys, I don't know if this is a router or a switch. I just took something I stole, right? But anyway, no, it could be an EX4200 with level 3 routing. I think it is actually an EX4200. So that does do basic routing, not a full BGP table. But let's not get into the specifics of that. So what happens here? I'm gonna do the limbo. No, all right. So if we did this, when you're in like a data facility, like an Equinix or I'll just stop there. Equinix, and you got a port. So like one connection here will be connected to one provider. Let's say this is PCCW, right? The next one, this connection here is to NTT. This connection here is the GTT. This connection here is the ATT. It's pretty much the exact same thing. You guys all have at home, but you guys usually only have one internet connection, right? You either buy from Verizon, or you buy from Comcast, or you buy from Cox, or Cogent. So you buy, who buys from Cogent? Is there a Cogent salesperson here? Good. All right, you buy from Cogent too. All right. So that's the same sort of thing. So if you think about it, if the traffic comes in and if it knows it needs to go from one location to the other, that's called routing. That's how the internet routes. Now you're going to see how this goes back to my Cliff Clavin example in about another minute. So what we have here is when you connect to these multiple providers, okay, they pass to you what's called the internet routing table. Okay? And what this internet routing table is a list of all the address announcements and all the networks it takes to get there. Once again, the war of the blue code. All right, so let's say if I'm on provider 3491, who is that, Dave?
PCCW.
That is PCCW. So yeah, if you guys want to be really cool, you can learn all the AS numbers like Dave and Alex do. If you name them, they'll know all 42,000. Okay, so they'll say, okay, to get to 54.88.0.0/16, which is a /16, so it's half of your 32 bits, 16-bit address, that's why it's a /16, right? To get to this address, you're going to go to 3491. The rest of these I made up, guys, so I don't think these numbers, they could be AS, they are AS numbers, I don't know if anyone ever uses them. 16509 and 14618. Actually, this is I think it's a ESPN.com, ESPN Go, Alex, address, you should recognize that. So they're saying to get to this address, you go to our network, then this network, and then you finally end up in the final network. So, and they're saying for this IP address space, of course, you go to our network, then this network, then this network, then this network, right? You kind of see how this is going. And then down here, AS2914 is NTT.
Yep.
So that's NTT. They'll say the same thing, and they'll say, look, for us to get to that IP address, it's only going to be right to 14618, right? So if this is shorter than that, everyone see how 2 is less than 3? It's the closed alligator mouth, right? The closed alligator mouth, right? So you say this is a shorter path. So what happens when you connect to these routers, right? These routers, and remember back, pass all this routing information. They say, okay, I'm NTT. These are all my routes on the internet. This is how you get to all the IP addresses that I can connect to. And PCCW does the same thing. And Verizon does the same thing. And all these tier 1 big bandwidth players have what's called open pairing policies. And what they pass is this information, and they give the full routing table. So what finally happens is when it comes into the router here, this is the IP address of, I think, ESPN.com. And you say, okay, how do I get here? And so the router then has all these route tables from all the providers. And it says, okay, on port 1, which was PCCW, I have 3 hops, right? I know I got to go to PCCW, the 16509. Who's that? Anybody?
Amazon.
I don't think it's Amazon. Okay, then this is the Go. This is the Go network, right? And on NTT, it's got 5 hops. I made some of this stuff up, right? And so it then goes through. So the router gets this information from all the different bandwidth providers. And then it will then pick, which one do you think it's going to pick? The shortest one. Oh, yeah, right, makes sense, right? So it picks the shortest path, right? And that's all how BGP operates. So if you think about it, we're going to go AS3491, goes to AX509. That could be as many different connections in between. It goes all the way over to the final location. So our mail is now delivered, right? Just as if we were Cliff Clavin. Right? And then there's our IP address. So, our mail turned into routing. If we think about it, when the first mail is picked up, right? When Cliff Clavin picks up that mail and takes it to the post office, that's just like when you're on your home computer and you connect to your home router. Does that make sense? Exact same thing. All your data goes through that home router. Your home router doesn't have multiple connections to make a decision. It's called, in the technical terms, it's called a default route. Right? So if you guys ever went to your IP network configurations and you saw your default gateway, that means you have one route out, and that's out through this home connection you have, okay? So you're going out this connection, and then as it goes through every single step of the way, every time it goes to a regional facility, that's another router. It's making a decision based upon its BGP tables it has from all the different providers. And we go through, right? And finally it gets to another home router, which goes to a local network. So, how did we get the outage? Anyone read up on it? That's the reason we're in the talk, so that's fine. So what happened, and I made an example, it's actually happened in Pittsburgh. What happened is that someone said, I now am going to announce a more specific route. So someone actually took the full routing table. I think it was a oil company in Pittsburgh, wasn't it, Alex?
Yeah, it was a route optimizer at an oil company.
Yeah, and they were a customer of Verizon. So they took all these routes, the full routing table, which is, I don't know how many millions of routes now. Anybody want to? It's a lot.
Yeah.
It's a lot. It's a lot, millions and millions of routes. And what they did, they said, okay, we now have a more specific route. And they did this for a good portion of the internet, right? And so for anyone that's announcing this /16, which is, as you think about that, IPv4, the reason why it's IPv4, it's 4 octets, so it's 32 bits of IP addresses. And so we're only using 16 in that network, but we're using 24 bits in this network. And so they started announcing a more specific route. The problem with the internet is that just kind of leaks all over the place, right? When you inject that route back into the internet, all the routers say, hey, this router now has a more specific route to where I want to go. So what happened is, if you think about it, this was what the routes were before, and now, what the hell, right? Now we have a /24, and I just put 666 there, I figured it's the devil, right? So what happened is that everything started, even if the AS path is longer, look, see port 1, it's 4 ports, even though it's a longer AS path, it's actually a more specific route, so it took over all those routes, right? And so all this traffic that was supposed to go to all over the world, all started going to Pittsburgh, right? So those routers are on fire. You know, the fiber optic actually started to melt. No, it didn't. But, good story, right? So the fiber optic's burning up, everyone's losing all their routing information, traffic was going bad, and it wasn't until someone was able to go in and notify the company to make the change, right? Who was that really fault? I think in the end it's Verizon. Verizon had the upstream connection. They allowed these routes to come in, and then they then shared all these routes to everyone else on the internet. When you're a tier 1 data provider, when you're a Cogent, Mr. Cogent, raise your hand. There you go. When you're a Cogent, when you're an NTT, when you're a PCCW, these guys all share their routes, and everyone says, hey, whatever you give me, I trust. And so when you have a client that misconfigures the router and sends it up to the tier 1, all the tier 1s then say, hey, you guys all take it, and that's how it brought down a good part of the internet. So the route came in there, and if you think about this, it then said, okay, instead of sending it to Europe, I'm now going to some player in Sao Paulo. Not really. And then this guy in Europe is like, where is my traffic, right? I need my traffic back. So anyway, people want to sometimes ask me, how do you see a BGP route? And a little audience participation here. How do you see a BGP route, everybody? Who said that? Yeah. Trace route. Who heard of a trace route before? Oh, so cool. You guys are so technical. All right, so that's why it's a Reston Tech Talks. All right, so what I want to do is I'm going to log in over here. I'm going to say, so trace routes are a way, and if you ever wanted to, you just open up the command prompt. You open up a new window, maybe make this a little bit larger, and let's say I want to do a trace route to www.espn.com, right? And you can see that I'm leaving here, right? I'm going out this 192.168.12.1. That's my default router, right? I then hit the Regis network. I then hit Comcast Business, right? So that would be 1AS is right. 1AS is the Regis. Comcast is the next one. I stay within Comcast. I'm bouncing around in Comcast. Now, I'm staying within that network a while. I could be bouncing from network to network to network, and then get a bunch of timeouts. I don't know what the hell it's doing now. It's just going to sit here for a while. But I want to show you something that's pretty cool. I'll show you what a visual trace route looks like. Let me bring it up. Yeah, that's my calendar. So Diana, the reason why I don't ever respond to your emails is because my calendar is that busy. I apologize. All right. Let me log in over here. Actually, switch. Actually, that's the wrong service. I want to show you something that's. This is a little tool that we, I just want to show you what a visual trace route looks like. All right, cool. Does everyone see this? All right. So what we have here is you can see how it goes from what these are. These are multiple monitoring points around the world, and they're all trying to get to this one final host at the end. And you can see based on the color, the different networks it goes to, right? So over here, we're going from Chupa, it then hits NTT America. It stays at NTT all the time until it finally hits DigitalOcean. See? On this one right here, we go from Linode, it hits Telecity Global, it goes to Linode back, NTT America, Telia, NTT. You can see how the trace routes work. So that is pretty much your BGP routes. And you can see, like, this is how the internet normally works. These would be like multiple people around the world trying to get to one final location. But if someone else goes in there and announces a more specific route, it messes everything up. So that is the reason why 5 weeks ago, none of you guys were able to get on Facebook. All right? And you weren't able to look at your cat videos on YouTube. And it was a tragedy. But anyway, I want to do that. So anyway, real quickly right now, we have to do a lightning round. So